There we go. Sorry about that. Yeah, basically, I unplugged everything from my computer, plugged it back in somewhere else, and unplugged it again and plugged it again here because today I was Captain Bob in my school. So I did a cool kind of career fair, I guess. I did a presentation on flight simulation. It was super dope. I brought my simulator. I'll pull pictures here. It ended like half an hour ago. I got home. Um, I had like 10 minutes to prepare for the stream. That's why it didn't have sound. Let me pull up some pictures because it was pretty epic. Um, Here, it's pretty funny. This is it in the back of my car. Of course, you can't see it with the glare, but you can just see it hopped in there. Do I have the screen share app? No, not today. But yeah, it was super cool. I'll probably give more of it in the future videos of just like a little glimpse in it. I might even do a like creator spotlight. And maybe even later I'll look into downloading the app and showing you even more pictures. It was super fun. Do you hear me all good? Still no sound. Let's see when this was from. Show timestamps. 3. Okay, so that was 2 minutes ago. Let me know if you can hear me. It looks like all the bars are in the green. So basically let me know if that's not the case. But yeah. So it was super fun. I taught probably 75 people how to fly. It was genuinely a fun experience. A lot of the common themes, it's fun with new pilots. A few, it works. A lot of the common themes are driving it like a car, not knowing how to use the rudder, and crashing. That's the last one. But but it was really fun to teach people how to fly because I learned a lot about flight myself. I learned it's oh, this is so cliche. It's like when the teachers are like, I learn more from the students than I teach the students. They just teach me so much. But like, basically, I learned a lot about like how to control the airplane, and I do have a story about feedback because I think feedback is important. Force feedback and project feedback. So it looks like it's loud and clear. It does say that its bit rate is super low, but we're going to assume that's not true. Um, but basically, don't judge a book by its cover because we were doing the career fair today. Everyone was just chatting along in the simulator, and this guy came up to me. We started talking, and he kind of judged the like control axes. He's like, "This isn't how it feels. This isn't how it works." And of course, I'm like, "Well, yes, it's 10% done. These aren't even hooked up to rubber bands, let alone force feedback or even bungee cords." So it's kind of like, yeah, I was training, not low. Um, okay, perfect sound. So so he, I was tired. I've basically all of today and yesterday been teaching people like just the basics of flying and getting them in the sim. Um, and so he's like, the rubber bands don't snap to the center; they kind of rock gently. And I'm a pilot, so I already know that. But I kind of just like asked more questions instead of I've discovered in life a lot of times instead of saying no or like just like I know that, say tell me more, or like when you are approached with negative feedback. So I was like, tell me more, and he started proposing solutions that I've never heard of before. Um, I don't know if they'll work. It might be easier to go another way, but my mind has been like blown by his solutions. One of them was to get a 3D printed. It's like I wrote it down somewhere. It's like APA or something. 3D printed APA, and you string it together uh, onto the yoke. You can like engineer the compression and its limits. It's some crazy filament that's exotic. He also was talking about ceramic filaments. I don't know if they would be good for a precision application because I think they do have shrinkage, but I learned about ceramic filaments. So really, one of the lessons I learned today was to not judge a book by its cover, to like take feedback and go grow from it. So, um, yeah, we have other things I need to do on the stream, of course. I can't just hop onto a stream without anything to do. Otherwise, I just stare at this stream for half an hour. But sounds good, good. How are you, man? I'm doing great. Really tired, but doing great. The hardest part in flying is communication, not flying. Yeah, communication is definitely a tricky part of flying. I know, and I would say crew resource management. Flying, there's the posters that say like, is push the stick down, see trees quicker. Pull the stick up, the trees get smaller. Left goes left, right goes right, and that's basically flying. Flying good is even harder than that, and I'd say flying, this might be a trick question because flying involves communication. So it's like flying is super hard because you're communicating while controlling, while managing airspeed, altitude, and everything else in that question bank. So yeah, definitely. Hardest part of flying is communication, not flying. It's a good quote. Alrighty. The first thing that I was supposed to do, I already failed. So let's jump to camera 2. Is this the right one? Nope. This one. It's very branded, but this one's the one I wanted. Here's our thing. The first thing on my list right here was have your simulator down here. But I'd like 10 minutes. It is right now in the garage. The two logistics we need for garage streams are a portable computer. I have a laptop. I can make it work. Audio. That's going to be harder because I have to wirecast audio from my phone somehow, like through a wireless mic app to the computer. Or I could just like wear it in one of my pockets or something. I don't know. That would be awful audio because this thing doesn't have a good microphone. We could also, and I'm also looking for a lav mic. So I'm looking at doing in-shop lives. These have been on my bucket list for a while. But yeah, this time I found a good wireless microphone that I can attach to like a camera or a computer, and I think that'll work really nicely because it's a lapel mic or a lavalier mic. Yeah. So yeah, some of the upgrades in the simulator. I do want to show you screenshots. I'm gonna make sure they don't spoil too much because I want to keep some stuff for the videos. But lately, I've been working. Yeah, we'll spoil it. Lately, I've been working on the controls. So this is actually not the most recent design. There are a few things I'm changing. Actually, it might be the most recent design. Yeah, it is. But this is one of the designs. There are a lot of things I'm changing. You see this right here? This is a potentiometer. We don't like those, apparently. Yeah, everyone I talk to is like, potentiometers are the devil. They're so inaccurate. You should get Hall effect sensors. So I'm thinking about changing back to those, and I think that might just be a little bit more fun. Let's hop back to the chat. And here we are. Let's see. So yeah, so the yokes, as I've shown you, we can hop back. Scene 2, I think. Yeah, so basically, I'm going to show you this all in the yoke video. So if you want to be surprised, close your ears. Plug your ears, I guess. But the yoke goes forward. It goes forward. I updated this funky rack and pinion thing here for a less funky rack and pinion thing here. And now, right now, I'm just working on strengthening the weak parts. And going for that. That's also how I do my workouts. Strengthening the weak parts. I don't know. But yeah, so that's most of it for the yoke. I am going to show you some CAD later. Or, I guess right now, because that's... Let's do that. Fusion 360. Alrighty, so... I also do want to bring up the topic this whole video is about. Um, do, 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 do. All right. I have Christmas music pulled up. I love Christmas music. Let me see. So I do want to have a conversation with you because these live streams are a perfect opportunity. But like, recently I've been, to be honest, it's been like fun to see like, should I make money off of this channel? There's like a bunch of different thoughts about it. It's like money is inherently evil. There's also the like people that say, if you're like, you can perfectly enjoy your hobby, and then once you put money into it, then you start not. Once you put money into it, it starts just ruining it. Money is a monster, and all this stuff. So I'm trying to like strike the balance between like, because I was doing a lot of things. World, gotta do this. You gotta have what it takes. But I would say that being running your own business could be just as hard. Uh-oh, it looks like it's frozen. But we'll pretend it's not. Uh-oh, that's not good. All right, how are we doing online? Can you see me? Can you hear me? Oops. I was getting so motivational. Darn. But yeah. Maybe it's CAD. CAD is ruining everything. How are we doing on the like whole very laggy? All right, are we still laggy? Probably. I'm probably like, ink, 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 ink. Let's see if this fixes it. Audio works, but camera is very laggy. All right, you probably don't need the camera too much, I imagine. I can also try to do other stuff. All right, so we're gonna continue. Let me know if it's like super awful and it's like intangible. Intangible? Ineligible. No. Intelligible? Like, unable to decipher. Let me know if it's bad. Alright, so I was basically lost my train of thought now. Fine now? Fixed? Great. Let's go on. Oh, so yeah. If you say you want to be an astronaut, everyone's like, alright, here's the steps to be an astronaut. Like, go for it. If you say you want to be a pilot, ideally most people would be like, yeah, that sounds super cool, man, do it. But I want to be do business with flight simulators. That is like my dream job right now. I want to build flight simulators for a living, but they're like, find a real job. So it's really interesting. I'm kind of like, should I like go for a real job and do it on the side, and then I could even like, if I have a real job, if I have a real job and do my hobby on the side, I could I could have all of my free time go to that, and I wouldn't have to charge anyone a cent because I'd have my real job. And then like part of me is like, maybe I figure something else out, and like if I could make this my real job though, I wouldn't have to have any I would have so much more time to work on this. So it's really like this internal struggle. Should I like make everything I'll put a smiley face in chat. I don't know. But if I'm like, is it worth like ruining the hobby over? Would like making money off of the hobby ruin it? So yeah. So like, what's your opinion? Like, also, does anyone have any like super cool tips? Like, I know a lot of people wanted me to sell flight simulators for a while, and so I started doing that. Um, so if you have anything like that, I'm wondering, like, should I sell my plans? That's something I'm starting to consider because it's hard to make money. It's hard to make money in this hobby. So maybe it is very niche, but I've seen today that there are a lot of people interested in flight simulators that just don't know about. So I'll put all this in my scrapbook, which is actually a collage of notebooks on my desktop. First thing you must do is find an education. Yes. Education. That's interesting. I love YouTube University. I kind of my thoughts on college are it kind of feels like a ripoff because you could own a plumbing business and make as much and it's in demand. Everyone has a toilet, or most people have a toilet. Actually, but everyone has a toilet. Everyone at one point breaks their toilet. Plumbing is a great job. You don't need to go to college, so it's interesting. So I'm like, yes, I do need a high school education, and I'm taking college classes right now, so gotta get my education. It's really important. I love learning, so I want to continue learning all my life. I don't know if I want to pay for it though. That's an interesting thing. If I do want to go for a traditional job, definitely need an education. If I want to be a business owner, I think if I get an associate's degree, that should be enough. The IRS isn't gonna go up to you and ask to see your bachelor's. But yeah. Also, what are your thoughts on education? This'll be heated. But yeah, I'll probably go to college. That's in my career path. For engineer. Basically right now I'm going as if I'm going to be an engineer, and then if there's a chance to take an off-ramp into my dream job, I'm going to do that. I'm going to go back in the chat a little. ATC communications, those are tricky. It's easier when you know the 5 W's, which I forgot. Hello. Did you complete your cabin? No, my cabin isn't complete. The shell of the second section that houses the instrument panel is almost done. AWU, I think that's super funny. This is the AWU. It's the auxiliary Wi-Fi unit. It's one of these derpy USB Wi-Fi adapters. I just replaced my my AWU with a MWU, a main Wi-Fi unit. And y'all are gonna yell at me for Ethernet, lack of thereof, but you see, Ethernet, I would have to run a 1,000,000-mile cable downstairs, which would be ugly, and I'd have to punch through the walls. All right. So yeah, audio works good. All right, I returned and it looks way better. Good to hear. Maybe the AWU was a thing that's awful. All right, it looks way better. Oh, and hello, Ismail. Welcome to the stream. Most of successful people do not have a college degree. Yeah, you don't have to have a college degree to be successful. I think college can make you more successful if you're learning about the right things. I've been in the education system so many years. I've seen how awful it is. But right now I'm at my high school right now I transferred into, and I'm in love with education right now because right now I'm learning real world skills, which is crazy. Calculus is what I'm learning, which is not a real world skill, but I do need it to be an engineer, and those are the types of things I get super excited about when knowledge applies. Or calculus isn't the best example because you're you take the integral of the derivative of the integral of the summation of the square root of the sun, and then you're where is that? What would you use that for? And they're well, if you're a semi-truck driver and you need to calculate the skid distance of your wheels, and your wheels are on fire, and you're right next to a taxi that's yellow, but anything else, no. But yeah, so I really like when math applies to like something realistic. Most people won't be calculating the arc length of a curve. They'll go into Fusion 360, click it, and read what it says. But yeah, so I really like. That was a tangent about math, but I really like it. What I'm doing now, because I don't have any English classes. I have a speech class. That's one of the things. English is, the way it's taught is just a bunch of essays. All right. Nah, you don't need an AWU. You need an APU connected to your PC. I have a main power unit. Would an APU for a PC just be like one of those little, like, fans or something? I don't know. No, that'd be the RAM. The RAM air turbine. I get later. Greetings. Oh, welcome, Javier. Yeah, welcome, Javier, Yummy, and Yum Yum. Num Num. I said, yeah. Welcome all to the stream. I think I have everything I want to talk about. We have a simulator update. I showed you the pictures over here. This is the most I want to give away right now. I like to keep things top secret, except for this, until I do the video. So the most information you can get is right here on the live stream and also in Instagram, the wonderful place. I also didn't share my screen, so you didn't see it. I'll share it. Here we are. Oh, I just exited out of it. We will find it under quick access. Boom, boom. Here it is. So this is the yoke progress. Ignoring my desktop, I'm doing dimensions for images and stuff. Also, I've just been super cluttered up here lately, so you can like see that reflect everywhere else. The moment when a pilot wants a RAM for a PC. Yeah, I gotta get a RAM for my PC, because, you know, all of the airflow that's going through my room, it might be able to power a fan. All of the airflow, yeah. You can just see my hair rolling around. All right, we're going to open Fusion 360, which is also known as Confusion 360. Let me, I think I have a thing, CAD. Where is it? Boom, boom. It's like this. All right, we're gonna let Fusion 360 load up, and then I'll share my screen because that is an important part of computer-aided design. We need a little Christmas right this very minute. Oh, where'd that go? Let me bring it back. I'll share my screen in a second. I'm struggling. Alrighty. So, here is Confusion 360. We're going to be designing today a, not part of our yoke assembly. Gonna go into section 2, start, this will be in under 2, yeah, it'll just be under 2. Right now, I'm kind of like trying to figure out a better way of doing my this. Is this what you see? Let me make sure it is. Actually, I can zoom in. That makes it easier for you. I just zoom into the place right here and hide the Windows bar. There we go. CAD man. Oh, and I won't have holiday cheer unless I have this, so there you go. Yeah, it has to be to the side, otherwise it's not Santa, it's just a grumpy person, right? Alright, so we are going to start our flaps module. We're going to have 2 pieces of hardware. One is a servo. I've already modified that in my electronics library. I'll just drag it in real quick. So we gotta save it before we enter anything. This will be the flaps let's just go assembly. The shortened version is much easier to type. Maybe I should go to college. So it's going to be in Section 2. Section 2 is for everything that goes to both the simulators. Section 2A is specific to the analog. Section 2G is specific to the G1000. That's how it's divided up. So Section 2, and this isn't a key, this is a flap. My bad. It's been a long day. Oh, I might be modifying something. So we're saving it as flap assembly. There we go. And so now I can drag components into it. I have a ton of electronic models in my library that I've been slowly growing. And the fire is slowly... Here's an servo motor I CAD'd real quick. So I'm going to start out with these components because I know I need these, and they'll just be floating in space until they have a home. I'll hide them, probably. And then we have also something else. Where did it go? We have a rotary thing. We're thriving. All right, so here's our rotary switch. I found this on GrabCAD, and I can use it to reference everything. I'm not actually going to 3D print a switch. That would be stupid. Actually, it might work. It might be cool to, like, if I go super deep into everything, to, like, have everything, like, modeled like that. But no, I'm not gonna, like, create my own wood from trees I have chopped down. But yeah, here's your holiday cheer, so I'm not clickbaiting you. And yeah, oh, thank you. Thank you, Javier. I'm really bad at pronouncing names. I hope I got that right. I think if you just, I think I should start making my components right now. So this flappy thing is going to have a few components. One of them is going to be a faceplate. One of them is going to be a left side plate. Another is going to be a right side plate. Another one is going to be a thing for the... Another one is going to be the servo and the rotary assembly. So we'll need two more parts. After that, new component, we'll have it... Yeah, I gotta have the hierarchy right. But we'll have a, what's it called? Left wall, we'll call it. I don't know. Whenever I'm looking through people's CAD models, I'm like, why did they call it a wall? That's dumb. And then I'm like, oh, actually, they called it that because they ran out of words. I run out of words too, so we're going to call them walls. They're the things that hold the electronics. There's also going to be a servo lever. Wrong lever. And then actually, what might be easy, part of me is like, do I want to laser cut it? Because laser cutting, you buy a sheet, you just laser cut it real quick, and then put them together, and it's super accurate, depending on your laser cutter, but it's really accurate, it's cheap, don't have to 3D print it, good DFM, designed for manufacturing. But also, at the same time, if I get a plastic part like this, I can have it one part instead of three. And if I have one part, you don't have to assemble it. So I'm thinking that maybe we have a component that's called, that's parent is this. We have a component called walls. Wally. Yeah, it'll be fun. We have a component called walls over here. We put the left wall in, we put the right wall in, we put the left wall in, and we shake it all about. So basically, we have a left wall and a right wall, and a middle wall. So the active component is going to have a middle wall too. And so those will basically be the spacers. So I'm going to, I really like Alan Glenn's Cessna 172 flight panel. I'm going to design it to my own specifications. I'm very particular about hole spacing and stuff like that, but if we go to its Thingiverse, we can find. Oh. It's like we can find this design. So I'm going to have the yoke lever, no, the servo lever, kind of like he did. He used an actual Cessna 172's control panel right here. I don't want to do that because then everyone has to buy a Cessna 172 control arm. And if I make everyone do that, we will run out and the world will collapse upon us. So it's just not a good idea. Let's see. So this is laser 3D printed, then laser engraved. I think it looks kind of like it is. This was super sneaky how he did it, but he actually just used blue tape and then laser cut into the blue tape, which, hey, that's awesome. So I might do that. I might look into screen printing, stuff like that. I thinking I want this. Basically, he has a lot of it. It's weird though, because he provided this CAD model with like everything sketched out and stuff, but then it's not actually all in the file, so it's a little weird. You'd have to like cut it up. But basically, I want to improve upon the arm mechanism and make it so it's primarily 3D printed instead of it does show the lever. Let me see. That's strange. It must be on the site. Let me go get that. Can you properly? Huh. Let me see. So it's possible I'll use this one. I do like designing stuff. Like it's a challenge for me to like think about how to design it. And I do want to have it all one part right here. So you can just print one part, no supports. And then like out of the gate, it's like 2-part assembly. So it's easy. Or I could have a 3-part assembly. So it's easy to ship, or like 3 walls and spacers and stuff. So I definitely want to see how I can do that. I do want it to be flattered though. It's a little tricky. I like this design a lot. I just like I like pushing the boundaries a little. Like pushing my boundaries, even if it doesn't accomplish anything. Let's see. He does show the 3D printed lever on his site. I just printed it. I'm gonna go back to his site. Glen. Here we go. So let's go. I think it's under avionics stack. Alrighty. So it looks like he has this part, this part, this part, the lever mount. Oh, it's glitching out again. My apologies. Huh. Okay, so that's really weird. So I know he has this part. I couldn't see the actual lever that the handle goes onto anywhere. So I'm gonna, because there are 2 knobs. One of them's a lever, and one of them's something else. I'm gonna see 6 pieces. 1, 2, 3, 4, 5, 6. All right. Yeah, it's weird. It looks like it's in this FreeCAD file. So I think I could just basically open up the FreeCAD file and print it from there. But this is one of the designs I've been looking at. I'm gonna try to make back up to it. I can't find it anywhere. This one isn't the right one. Yeah. Oh, here it is. There's a mount for it or something. Pointer and lever. Pointer and lever. I'll just control F it. Never mind. Alright, so I can't find it. So I'm basically going to, I could take this design and go from there. I could also make my own, and I think I like to make my own a lot. It's just fun to build them myself. So what I did was I have a folder in my Cessna 172 simulator folder. I'm gonna probably end up putting this on GitHub someday. Where did it go? Section 2, flaps. I have so many images. So I have this whole folder right here. I go on eBay basically, and I find a flaps panel, and then I basically replicate it. So there are a bunch of different styles of flap panels. There are short ones, thin ones, fat ones. Here's the lever assembly that we're talking about. I couldn't find it. I'm probably looking in the wrong places. Here's the handle, some good reference images. I'm gonna throw that one. Oh, we'll rename it something. Put a 1 at the end of it, and then it's different. So we have all of these handle images from eBay. And so I basically take these and go from there and challenge my brain, because I think really, just like when you're learning CAD, if you're wanting to learn more CAD, you can copy people's designs and put your own spunk on them. Like, I really want to have this root right here, this extrusion. I don't think his simulator had it on his flap handle. Where is it? Exit. His flap handle right here doesn't have that little thing. I think it might be a like 3D printing make it easier thing, but I think I just want to print it with support. Right. So yeah, here's what we are doing. This is someone else's thing. I want to like kind of take inspiration from it, make my own, and I'm gonna just basically start from scratch. I want it to be as few parts as possible, so that'll be interesting. Let's see. I want to see. Oh, is there humming in the background? We'll figure it out. Alright. Oh, that's too bad. Your joystick broke. Sad to see it here. Alright, I'm gonna just read through the comments real quickly. Interesting. I'll have to look harder for it. Can you properly laser engrave PLA? Probably not very much. I'm gonna look into some thin sheets of ABS. Not ABS, acrylic. I just printed the whole assembly, 6 pieces to it. Back up to it, point and lever. Alright, I'll look harder later. I tried printing this a while ago, but I had the same problem. Position indicator. That's so weird. This is the flap position indicator, but I don't have the actual real one. So there's also this lever mount, but I don't have this metal piece, so I'd have to probably buy one, I think. Also, his design uses a potentiometer. These are notoriously hard for me to explain to people how to connect them. They're probably pretty easy, but I just haven't. The easiest way to do it is to connect it to a joystick and then coordinate the joystick, like find a way to calibrate the joystick to the flap axes and make sure everything is good to go. I'm going to use a 4-position switch. That might be easier. I know in these, I feel like it's more of a smooth like movement instead of like a definite like pop. So the detents in the switch will kind of maybe throw it off. So I might try to make a design with both a potentiometer and a flap and a rotary switch. And thank you so much, Jay, for all of your advice. It's really helpful. Thank you. Let's see. Oh, I hope you fix your joystick, Yummy. Let's go back to business, as they say in the song. Let's get back to business. Oop, there we go. So I really like this guy's panels because he's he has them all modular like this. Mine, I'm printing a basically huge throttle panel like this, and that's my throttle panel is pretty big. Let's go on to back to Fusion 360. Oh, I forgot it's super zoomed in. Gotcha. I'm gonna look one more time because I really don't see it. Maybe this is taking too much time. Yeah, I'll look later. But here's my yoke assembly. We don't need that right now. We want this flaps assembly. Very nice. So it looks like he does have it up there. I just skimmed it and missed it. I've missed it my whole life. Alright, so we have, what I'm thinking is we could make a left wall, a right wall, and a middle wall. And if you want to have it laser engraved, you'd just have a left wall and a right wall. And then you'd use spacers to go between the two. So that is one way of doing it. I might also instead just kind of like reference geometry from some of this stuff and say like we have the left wall and we have the left wall and the right wall, and then from there we have three part. Just basically have one part that's designed for 3D printing, one part that's designed for laser engraving, so that it keeps both sides of people happy. So yeah. Oh yeah, and my email is oh yeah, yeah, I'll put my email in chat real quick. I think I have yours, if I'm correct. I won't pull it up. That'd be, but yeah, there it is. I'm going to look one more time. I'm curious. So it's not in any of these. Panel, okay. Map control. That's not it. I'm really curious. Thingiverse, STL. Alright. Mounting bracket. Mount. That's crazy. I'm lost. Faceplate. Yeah, so it looks like I couldn't find it. That'd be super helpful. Thank you for the offer. And on chat it says you could always use FSU IPC and a potentiometer. That is true. FSU IPC and a potentiometer, and set flaps 1 from like a voltage range here. Set flaps 2 from a voltage range here. Set flaps 3 from a voltage range here. Since I could also I could make a flexible design, because who said we had to have one or the other? But these D-shaft or these plumb shaft rotary encoders and potentiometers, these are actually exactly the same because they use the same switches or the same knobs for them. So I can design it around a potentiometer, then shift it over to a rotary switch if I want. So I'm also going to pull in a potentiometer. Why not? Let's go there. So yeah, we also have a potentiometer. I'll just make an assembly, kind of like I did with this walls. With walls, I hope this is the right scale. I'm gonna make a new component that is instead going to be electronics. So I'll just put all this stuff in there so it doesn't clutter up my my file tree. So we have these electronics, and the nice thing here is we can turn them all off and on at once. So if we have like, it's like an avionics master switch. Yep, so I'm considering FSU IPC. MobiFlight, it's a little trickier. I have to do some fantastic stuff. And welcome, Noah. Welcome to the stream. Glad you could make it. It'll be fun to see when it's done. Detentless encoder. What's a... I've never heard of that. Is it just a endless encoder? Huh. Strange. Also, why did my thing turn to Bing? No one likes Bing. Just kidding. But I like Google Chrome because it like shows you videos usually. That's a just side tangent. So we have the electronics we're going to kind of design it around. We're going to start by doing the faceplate. The faceplate is the keystone of this design. If I get the faceplate wrong, it'll be a little tricky. So now we have a sketch. We want the front to be the front right here. And we're going to make a centered rectangle. I want the, I'm going to turn off the electronics. And right now, I'll dimension it later. And over here, we're going to pull in a, something over here. So I have my, this is the old files. Those are the good days. But here's the new files. Boom, boom, boom. Section 2A is my work so far. So I'm going to pull in the panel. Section 2A and Section 2B will be the same, but I've only modeled it on Section 2A. So I basically also wanted to see how he like did it. So a lot of reverse engineering is used to forward engineer. I'm going to do all of my designs in Illustrator, not Illustrator, Inkscape. I don't have Illustrator. I can't do it there. But he basically just made a box with patterned holes. His didn't line up enough for my images. So what I did after that was I had a bunch of reference images just to double check. That's what all of these reference images are. I can pull them up and we can make them work. So one of my questions is there are like three types of flaps. Also, they each have different speeds, so I need to make sure it corresponds to my simulator. I might want to make the speeds like parametric, or like you can change the words, so I can't have an image of a text. I have to have the text raw. That's another challenge. Here's what it looks like blank, and then basically these decals are applied. They're either decals or screen printing, I'm not quite sure. So here's basically how it functions. There are also ones without faceplates at all. So this one, for example, don't know what part of a Cessna it is, but instead of having like, I'll make a drawing. And so instead of having the 4 screws to screw on the panel, you can't see it. Yeah, you can. Instead of having that, they have the 2 screws, it looks like, as part of the panel that doesn't screw on. And then there's like a recessed hole. You can see it right here, but I don't know how I'm explaining it. But basically, instead of having this auxiliary module like we have over here, this fine person is lifting up the flaps. Instead, we'd have something like this where it's kind of indented into the panel. So these are some different designs. There's also the one with the screws in the middle. I've never seen this one, so I know a lot more about Cessna 172s now than I did a few days ago. These are the same image. No, they're slightly different. No, they're the same. But there's also fat ones and skinny ones. This one's a bit fatter, I'd say, because this one's skinny and tall. I'm sorry for body shaming them. It's just science. There's also this one from a Cessna 337 I thought was pretty interesting. This one I'm going to disregard because it's a 337, not a 172. But it has a pretty cool mechanism. I just thought I'd show off. It even has backlighting capabilities right here. That was interesting how they did it. How they basically just put an LED into it. Kind of. Oh, I'm tired. Anything else? Cessna 177 had a pretty ugly one. It looks like they photocopied it almost, which would be good for me because it'd be straight on. But it isn't the right. I also like how their flaps are in fractions. That's just funny. Here's the mechanism in their airplane. Not really sure how it works, to be honest. Maybe I do. I think actually if it might be, so there are two micro switches. So this, I could do it in the real world with some logic programming. This is the actual flap mechanism, and this is why these designs always take more than exactly 1 hour. But if I have a click one way and a click the other way, you can tell based on the amount of things it's clicking which position it's in. So if it's clicking the bottom one, I guess. This is insane. What am I doing? I guess it's actually, let me check something. So up, down. I don't know how this mechanism works. I gotta reverse engineer it. But I think what happens is if this hits one of the micro switches, it knows it's in one position. If it hits none of them, it's in one position. If it hits one of them, it's in this position. And maybe even if it hits both of them, it's in one position. So it's like something. I don't know. This is strange. If anyone's like a mechanic or something and knows how this works, I'd love to see how it works. Or even if you like take apart Cessnas for fun. I have no clue how that works, and I would love to find out. It reminds me of the gear mechanisms that have like the micro switches for up and down. I'd have to think about this because I have like tons of those micro switches. You just snap some in real quick. Strange problems. Oh, and welcome, Isaac. Normal encoder, but doesn't have the clicks in it. Gotcha. That would be cool. Normal encoder. Detentless switch. I'm gonna. Let's see now if it. I can't really find anything good for detentless rotary switches. I think kind of the whole point of a rotary switch is to have that little click. Interesting. I guess free rotating rotary switch. There we go. Strange. Strange stuff. I guess a potentiometer would be the best free rotating, like detentless switch. A rotary encoder, I was thinking about that, but it would be super tricky because you would have it basically say go down one flap, go down one flap, go down one flap, go down one flap. But the flap like go down commands would be so close to each other that it really wouldn't make sense with a rotary encoder. So I'm stuck with potentiometer and rotary switch for now, unless I can make my own rotary switch out of micro switches. But I think those are the main options right now. How many positions does flaps indicator have? I believe it has 4. Yeah, 1, 2, 3, 4. Used to have 40 degrees of flaps, which would have made it perfect for my 5-position switches. But those are only in like pretty old 150s. Darn it. Four positions. All right. So okay, so yeah, since there is 2 bits from 2 micro switches. All right, let's go back to that image. I want to see if I can decipher it now. You've given me new powers. So it looks like there is a... I don't know how they both connect at the same time. I think that's the middle position. But it looks like this hammer thing. When it's all the way down, it hits one switch. So flaps down. When it's one from all the way down, it hits one, but not the top. It hits this rotary switch, but not this micro switch, not rotary switch. When it's here, it hits the top one, but not the bottom one. And then when it's in the top, it hits none of them. Yeah, I think that would be a cool design. So yeah, that would be a lot of a lot of possibilities. Let's see. Strange. That blew my mind. Thank you so much, Jay. I might have to design one like this in the future, like after I do my simple rotary mechanism, I think, because this is really cool. And you can tell when these are on and off. Sorry about the microphone. Because they have a normally open and a normally closed. So it does give both open and closed information. So you could easily take that into MobiFlight and write a really ugly piece of configuration that says when the top switch is on, but the bottom one isn't on, do this. When the top switch is on, but the bottom one is, do this. When the top one is and the bottom is, like that. So that would be pretty good. I'm gonna put that on the drawing board probably. Why is it called a drawing board? I'm not good at drawing. Oh, it's because you draw out the plans. Duh. But I think I'm gonna shelve that project for now. But I do want to come back to it because that just sounds like a perfect combination of like getting pieces to work together and also getting the code to work. So 2 micro switch flaps. Yeah, for sure. And another option is honestly the easiest option would just be to get like a 3-position momentary switch, click it down for down, 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 and then click it up for up if you want. So that would be a way easier system. But yeah, this is a complicated problem. When I make it complicated, it's pretty simple. I could have probably started designing like half an hour ago. But yeah, I'm gonna design the faceplate really quickly. I'm gonna show a few things. I want to just design the faceplate, and then I'm gonna take my siblings Christmas shopping. But we're gonna see which one fits best to this canvas over here. If we go into this sketch. So basically what we're going to do is insert a ton of canvases from my computer. Wish you could just drag them down. That would be fun, but what's the point of that? Right now I just got to choose between the flaps, you know. This panel specifically has the 4 holes. So we're going to match it to one with 4 holes. I think that's a kind of good plan. Let's match it over here, and we're basically going to just try to line up the holes, and theoretically they would all line up. Bringing forward the opacity. So here's one of the holes. Scale it down. Maybe I should try to center it and then try to line it up. But we have the holes over here. I'm going to turn off some of the other canvases. Is this the one I just added? No. We're good there. Turn off the bodies too. And they should turn back on later. Turn off this. Oh, that's awkward. Just turn off the bodies. So here we're just looking at the sketch. And the holes line up pretty okay. This is actually doesn't happen all the time. So you can see these bottom holes right here don't necessarily line up with the ones shown in the panel. I might try a more top-down image, but this just gives you a rough estimate of where everything is. So I'm going to press enter. This is now a canvas. Congratulations. I don't know why my timeline is all the way over here. That's a bug. Shouldn't do that. I could try some of the... I had a surprisingly low amount of these 4-hole flaps right here. I'm gonna insert another one. Same time, same bat station. This one would be super nice because they gave me this centimeter grid, which is like, wow, no one does that. But we're gonna go with this one. Put it on this axis. Ooh, it's a little jumbo. We're gonna flip it around. And eventually, if you flip it enough, it gets flipped the right way. I could also rotate it, but it's fun to apply transformations. Scaling it down, scaling it down. Also, this one, if we do this one looks like it is too fat. So it looks like it's for a different Cessna than... Oh, actually it fits up. It actually fits. So we can let this one pass if it wants. Its whole position is actually perfect. I think the other one was just too tall. Also, make sure to never body shame your switches. They'll be very angry. So yeah. So this is a good canvas. What I have done in the past is made a copy of this, shifted it over to, made a duplicate of this, and then like made it into new design, imported that new tiny little sketch design into it. I'm gonna see if I can derive. I'm gonna actually finish this sketch, make a new sketch so I can just derive the sketch. I'm in the panel support over here. I'm going to hide the stuff I hate. No hard feelings. We know it's all up to scale, or should be. What's this one? So this is the one we want. We want a sketch on the same plane as this sketch over here. This is a new sketch. We're going to hide the sketches. Oh, that was dumb. We have a sketch right here. So I did this in the wrong place. One sec. I'll just do it in the wrong place and move it. It's not a good best practice, but we're going to shift it anyways, so it isn't like a mission critical type of deal. But we have this over here. We're going to fillet the edges. Oops, got ahead of the put the cart in front of the horse. Then the horse got spooked and bucked me off. Not an offset, a fillet. So we're gonna fillet these edges right here. I haven't read the chat in a while. You probably are like, we can't hear you. Also, your background is on fire. And I'm like, let's see. So it looks like a radius of 0.15 inches is more or less good. But is it good or is it perfect? Yeah, and I'll have to shift to millimeters. This should be square. It's just had its better days. So we'll fix that. So basically, I'm going to make a rectangle right here. Trim it. And I'll use the trim tool right... Actually, gotta make another rectangle. Now I'll just make lines. It's a lot of like super crazy decision making that is... It's like hard to walk through with, but I just made this part because if you look at new ones, there's a brand spanking new one over here. It is all square, and then you use them, and over time it wears down like this. So I might even make one that's weathered and just like sand that off to like have an old Cessna 172 type of feel. Part of me really wants to make a weathered simulator like that. Oh, I just trimmed that off instead of filleting it. But this is all squared, and we're going to make a slot down here. So the slot command is right here. This is Fusion 360, by the way. That's what I'm designing everything in. nickname is Confusion360 because it takes a while to learn. 0.06, let's say, maybe more, 0.075 inches. I think that's about right. And then as for height, I really want to dimension the height from here to here, or from there to there, 1.25. Let's see how that looks. 1.2. That looks about right. The Cessna was designed in inches, so it's usually pretty inches friendly, kind of. All right. We have these circles that must be dimensioned. We're actually going to take that geometry later from the panel itself. Right now I just want to extrude it and show you what it'll look like. Turn on the bodies, and once we extrude that, it'll look like this, although not as thick. It'll probably protrude like 3 millimeters. So it would be like this on the panel. So this is what we created today. I'm going to work later on this, probably a lot more off camera, but I just wanted to show you how I go from kind of a drawing, an image, 52 if if you count them, but this is how I go from an image, choose the best one. I even go through the maintenance handbooks, find sketches, and try to find which one goes to the best one. So right now, I can take questions. If you all have any questions, anything you want to ask before I leave, I'm gonna wait till I did the holding my hand up thing in my stream because because you see this 5 minutes later. But but basically, any more questions, I'd be happy to answer them. Other than that, I don't think I have very much more. I'm gonna catch up on the chat. I'm all caught up. Today there won't be that that monthly Discord chat thing. Probably hop on maybe sometimes during the holidays. But yeah. That's been an hour and 8 minutes, so yeah. Feel free to go. I don't know. Alright, that was a super fun live stream. I'm going to see what I can do with the power of electronics and CAD off camera. I'm actually designing this for a seminar. So if you're not a part of Flight Sim Association, you should get a free account and just then you'll get a notification when mine is going live. So yeah, I'm planning that. That's what this is for. I kind of like to hop around in the simulator. You'll notice I did the switch panel first, then I did the circuit breakers, then I did the yoke, then I did the other stuff, then I'm doing the flaps, which is on the other side, and I started with something you'll never use. It's all over the place, but it was really nice hanging out with you, and now I'm going to get out of my fighter pilot jumpsuit and go shopping. So yeah.